So, Vanakkam. So, we will continue our lecture on engineering seismology. So, last few classes we talk about the earthquake, so how it is occurring, where it is occurring, what is the earthquake sources and how to classify the earthquake. So, now when earthquakes are occurring, we told that there was a vibration created. That vibration will be propagate throughout the earth. So, that we call it as a basically the earthquake vibration or the waves. So, how these waves are propagating? What are the different type of waves caused by the earthquake? So, that we are going to understand in today class, okay, which is called as a theory of wave propagation and seismic waves. So, if you look at that the earthquake is basically originating at focus due to the breakage of the rock. Okay. So, this breakage of the rocks basically it releases a rupture, okay, it releases a vibration, it releases a some kind of the rupturing phenomena which try to transform throughout the region. So, depends upon the rock type. Okay, so one side this will be propagating more, one side it will be propagating less from that. So, the earthquake begins at the earth focus with the crust rocks and then spread outward all the direction. The edge of the rupture does not spread uniformly, it depends upon the rock. The progress is jerky and irregular because the crustal rocks vary their physical property from the place to place. So, where it is weak, the propagation will take place larger, where it is very hard, the propagation will take place less. Similarly, there is a overburden pressure, so where that also controls this kind of rupture phenomena. So, this rupture phenomena basically, okay, so occurs on the rock where there is a rough patches which is called as a asperities. Okay, so you should know what is the change of the fault direction and structural complexity that act as a barrier for the fault to slip or stop the propagation of the rupture, that is called as a barriers. The extent of the fault rupture depends upon the variation of the strain on the rock throughout the region. So, the rupture continues until it reaches a place at which the rock is not sufficiently strained to permit extent. So, where the rock could be able to stop that rupture, up to that it ruptures. So, during the rupture the adjacent side of the rock spring back less strained position. During the rupture the rock sides of the fault rub against each other, so that some energy is used for the frictional forces and the crushing of the rock, and other energy can get passing through that particular material. So, that energy transformed in the form of waves. Okay. The wave basically consists of the disturbance of material or media that carries energy and propagate. So, when I speak actually I will basically create a vibration in the air acts as a medium to reach my voice to the person who was sitting opposite to me. So, that depends upon the medium, the disturbance, the level will reach longer and shorter. So, the material that wave propagates generally does not move along with the wave. For example, when I speak, the air is a medium. So, this medium does not move along with the wave, only the waves are move, but the particles in the medium will vibrate to the vibration. So, the movement of the material that generally confined a small motion is called as a particle motion. So, the particle in the material will basically vibrate. So, after the wave passed, the material usually looks like a did before the wave. Okay, the material does not change anything, but the particles in the medium will undergo a disturbance, but it comes back to original position. So, near the source of the strong disturbance, large explosion or any other place where if the particles are separatable, then you will get a displacement of the particle. So, that is why you see that surface displacement due to the earthquake. That happens when the particles are have a tendency to move due to the vibration which occurs generally on the very large vibration level. The source of energy created the initial disturbance or continuous generalized disturbance, and resulting wave propagate travel out from the disturbance. Because of their finite energy confined a short duration of the disturbance, the wave generated by such source will spread out during the propagation, become a smaller attenuate and distance away from the source with the time after the source as vibration. So, basically the waves will be created by the rupturing that wave will move along the material. So, the material in the particles in the material will respond to this wave and it moves and then comes back to original position. So, if there is a chance that the particle can permanently displace, you can see a ground displacement in the phenomena. So, these waves basically as mathematically represented by the some kind of graph or a sine wave. For example, this is how the wave is mathematically represented. So, you can see this part from initial to this is the amplitude of the wave. So, from starting up this position to this position basically, so is called as a wave length. The frequency is basically the 1 by t or the period. Okay, so this basically implies the wave parameter. This is the peak. So, this is the trough. Okay. So, this wave generally propagates on all the direction. So, the ray path is basically the wave how the propagates. So, the ray path with makes angle with a particular circle or some particular position, okay, a perpendicular angle. So, that is called as a wave front. Okay. So, that depends upon the how the wave moves, how the particles respond to that particular wave, the waves can be classified. Okay. For example, this is the origin of the wave, it moves with distance with different time. Okay. So, how these particles in the medium respond to the wave, based on that the wave can be classified as a different type of waves. So, in general the wave basically when it propagates from one position to other position. So, it interacts with the medium where it travels or it interacts with the soil. So, where there are four phenomena of interaction happens. One is the refraction, reflection and dispersion and attenuation. So, these are all the wave will propagate from one medium. Okay, when passes from one point to other point, where the medium will undergo this kind of transformation or a wave propagation. So, the refraction is basically the wave travels from one medium to other medium. For simplicity, we can assume that the seismic wave occurred at a rock which travels from one rock type to other rock type. How the waves are change its direction due to change in the material type, that is called as a refraction. So, you can see that velocity in the rock 2 type is greater than the velocity in the rock 1 type, where you can see that the wave angle changed from this position, original position to this level. So, similarly, the velocity of the rock type is less than the velocity of rock type, you can see that wave changes like this. Okay. So, then the reflection is basically the wave hit the surface and reflect. So, part of the wave parameter, this is called as a wave reflection. This you have seen in the Berkeley and the light and then some physics experiment in the school days. The dispersion is wave get the frequency changes, a duration of the wave changes due to the medium changes, that is called as a dispersion, or the separation of the waves like this is called as a dispersion. So, the attenuation is basically the reduction of the wave signal due to the medium property is called as attenuation. The increase of the wave signal amplitude due to the medium property is called as a amplification. So, the attenuation amplifications are opposites. Okay, attenuation is less, amplification is more. So, this is how the wave propagates. So, based on this propagation and how the particles in the medium respond to the waves, the wave can be categorized as a two major group. One is the body wave, another one is a surface wave. So, the body wave again can be categorized as a two category. One is the compressional wave, another is the shear wave. The surface wave can be categorized as a two category. One is the Love wave, another one is a Rayleigh wave. So, all this depends upon the particles motion in the medium. So, the one dimensional wave propagation basically explains how this wave can be theoretically propagation can be theoretically understood. So, the wave propagation stress waves can be easily understood by considering the unbounded infinite medium. So, the infinite one is extend infinitely in the direction of the wave propagation, example a long rod or a bar. There are three type of vibration we can create in that. One is the longitudinal vibration. So, rod extend and contract without lateral displacement. The torsional vibration, rod rotates about its axis without lateral displacement of the axis. The flexural vibration, axis itself move laterally, this little application in the soil dynamics. So, we will be talking more of longitudinal and torsional vibration. So, for example, this is the very long rod. So, where the waves are propagating in that. So, the particles in the rod will vibrate back and forth for the wave. That kind of motion is called as a longitudinal waves or a P waves, okay, a primary wave. So, if the same waves when it goes, if you apply a rotation, the particles will basically vibrate perpendicular to the direction of the wave, that is called as a S wave or P wave. So, that we can create by rotating the rod. Okay, this is why by pushing the rod and pressing and releasing. So, then the particle movements which happen plus the flexural, that is called as a surface wave, which we will understand in detail in the coming. So, this can be explained by considering the long linear elastic constrained rod with the cross section A, Young's modulus E, Poisson ratio V and density rho. Assume that the cross section plane will be remains planar, the stress will be distributed uniformly over each section. Okay, so then the wave propagation is controlled by the equation. So, it is proved from the explanation, theoretical explanation is the material property, okay, which controls a wave propagation is actually a modulus, okay, and then the density. These two materials are basically. So, I ask the Kramer, my TS to derive this and upload a derivation for the wave propagation, which is also available in the most of the standard textbooks which is used for the earthquake engineering. So, the longitudinal waves basically makes the particles to vibrate back and forth and which is controlled by the constrained modulus and density of the material. Okay. So, this is how it taking place. You can see very closely, this is the medium which it travels. So, when the waves coming, you can see this is a particle. So, this is basically a wave. When wave comes, you can see that the particle motions are contract and extend. So, this kind of phenomena happens, that wave is called as a P wave. Okay. So, where the particles of the motion, so along the direction of the wave where it expand as well as contrast. This kind of waves is called as a P wave. So, the torsional wave where you rotate and create a torsional wave, the particle motion of the constraint to the plane perpendicular to the direction of the wave, the dynamic torsional equilibrium requires to make this unbalanced force to bring to the equal. So, where the torque applied and the polar moment of inertia plays a role. So, which is basically constrained to the shear modulus and density of the material plays a role. So, if there is a change in the shear modulus and density, you will get a change in the wave propagation of this particular type of wave, which is called as a S wave. Basically, the S wave is called as a Vs, the P wave is called as a Vp, which is again interlinked with the Poisson ratio. So, this is how you can see, this is the standard relations used for express the ratio between the Vp and Vs. How the Vs basically occurs? So, the Vs waves are occurring like that. The particle in the direction of the wave move perpendicular to the wave direction. You can very carefully watch the particle. You can see how this moves basically. See, it goes up and down. So, these kind of waves are called as a surface wave. Okay. So, this kind of waves are called as a shear wave. So, where the particles are moving up and down along the direction of the wave. So, the another wave is basically a Love wave, which is basically defined and explained by using the semi-infinite rod. So, this two type of surface wave you can see, one is a Rayleigh wave, which is the plane wave, another one is a Love wave. So, this was actually invented by the scientists Rayleigh and Love. So, where they found these waves are occurring at the different than the P and S wave, which is occurs at the surface of the material rather than the stiffness of the material. So, basically these waves we can see here. So, this surface the waves, this is similar to S wave, but it is not occurring at the whole body, it occurs at a only surface. You can see the particle motion, the particle basically rotates, you can see how it rotates. So, these rotations are larger in the surface of the material and lower at the bottom of the material. This kind of waves are called as a Rayleigh waves. So, similarly the Love wave, which is like a snake. So, where the particles are move perpendicular, but it is movements are large at the surface and less at this one. So wave propagation, it is horizontal direction, it's perpendicular to the horizontal direction, not on the vertical direction. This kind of waves are called as a love wave, which is invented by the scientist called Love. So when earthquakes are occurring, all these 4 type of waves will be generated. So depends upon the location, you can experience a particular wave dominant, particular wave negligible. Okay, that we are going to see in the part of our course. So these wave characters are very important to understand the earthquake. So basically the P wave or compressional wave or primary wave is the first wave which comes due to the earthquake. So where the altering of compression same direction as the wave propagates. So it has a 5 to 7 km per second speed in the earth crust, 1.5 km in the water, 0.3 km per second in the air, the speed of the typical velocity range of this compressional wave. So generally smaller and higher frequent than the S wave, surface wave, and then the P wave is liquid or gas, the pressure waves including the sound waves. So as I told you that yesterday people felt vibration because of this P wave and sound wave. So secondary wave or the shear wave is called as a S wave. So this is actually alternating the transverse motion. Particle motion is it in the vertical or horizontal plane. It has a velocity range of 3 to 4 km in a typical earth crust. So the S wave do not travel through a fluid. So this property is very important. S wave do not travel through a fluid. You try to understand why S wave do not travel in the fluid by googling in yourself in the Google. You can get a nice video explanation for that. So S wave travels slower than the P wave in a solid and therefore arrives after the P wave. These informations are very important for interpreting the wave type in the seismogram. So the love wave, the surface wave or long waves travels horizontal motion perpendicular to the direction of the propagation, generally parallel to the earth surface. It has a velocity 2 to 4 km in the earth depending upon the frequency, faster than the Rayleigh wave, decrease in amplitude with the depth, dispersive, velocity depend upon the frequency, and low frequency propagating higher velocity, lower frequencies penetrating to the greater depth. Rayleigh wave, surface wave or long wave, ground roll, motion is both in direction of propagation and perpendicular to the propagation. It ranges from 2 to 4.2. So dispersive and amplitude decrease with the depth, appearance like a water waves. So when you throw a stone on the water body, you will get a waves. No, that kind of waves basically a Rayleigh wave. So the depth of penetrating depends upon the frequency. Low frequency is penetrating to the greater depth. So high frequency penetrate to the shallow depth. So this is the type of the wave which you generally experience in the from the earthquake. So basically the earthquake can causes a 2 type of wave. One is that a body wave which is again a 2 component P wave and S wave. So which travels body of the earth. Okay, that is called as a body wave. Okay, so the another one is a surface wave which travels surface of the earth. Okay, so which basically called as a surface wave. So the particle motion at the surface is very large, when the deeper level it reduces. So and the wave speed also depends upon the frequency. So the highest fast wave is a P wave which travel very fast. So the slowest wave will be the surface wave which reaches very late. Okay, so so in between is the S wave. So when any vibrations are occurring, all this wave will be generated. Depends upon the location where you are located, you can find a particular wave you can feel or particular wave you can record. Okay, so this plays a very important role in understanding the earthquake waves and the earthquake distance and where the earthquakes are occurring. Okay, basically the interior of the earth, we seen that plate tectonics, we told that earth has a 4 major category like inner core, outer core, mantle and crust. We told that the outer core is basically a liquid. So how they done basically, they created a vibration and tried to record at different place. They found that a particular zone there is no propagation of the S wave, which we have seen that S wave doesn't travel on the liquid part. Then they categorize that zone as a liquid. Okay, that is what is happened in the when categorizing these waves. This plays a very important role to characterize a materials in the earth and also to classify the materials, to understand the geological explorations and find out a material types okay, the mining materials in the ground using the seismic survey. So these seismic surveys are predominantly used by the mining people for getting the mining materials identification and excavation and all those things. So with this we will close today lecture. So we talk about the wave type and wave character. You should know, remember all this wave behavior and wave character, so that when you are going for the interpretation of the seismic record, this data will be useful. So part of today class, one is that you should go through the derivation for how the material property affect a wave propagation. As we have seen that the P wave is affected by the constraint modulus and density, and S wave affected by the density and shear modulus, okay, or polar moment of inertia, and then the love wave and other wave affected by the the shear properties of the material. So that will help you to model parameter selection for the seismic wave propagation or P wave propagation in the later stage. So with that, with this I close this lecture. Thank you. So we will see you in the next class how this wave propagation or the theory of wave propagation can be useful to interpret a earth interior material type using this. Okay, how you can identify a earth signals or vibration signals from this wave propagation theory.